Welcome to your comprehensive interactive study breakdown on energy changes in chemistry. Today we will explore how energy is transferred during chemical reactions, classify reactions as exothermic or endothermic, interpret reaction profiles, and master bond energy calculations. These concepts are essential for your GCSE exams and bridge theory with real-world applications like hand warmers and fuel cells. Let's map out the core concepts. Every reaction involves breaking bonds in reactants, which requires energy, and forming bonds in products, which releases energy. If more energy is released than absorbed, the reaction is exothermic and the surroundings heat up. If more energy is absorbed, it's endothermic and the surroundings cool down. Activation energy is the initial energy barrier that must be overcome. Turning to our core study notes, reaction profiles are graphs that show the energy changes during a reaction. The reactants start at a certain energy level. The activation energy is the minimum energy needed to start the reaction, shown as the height of the peak above the reactants. The overall energy change is the difference between the energy of the products and the energy of the reactants. For exothermic reactions, products are lower than reactants. For endothermic, products are higher. Now let's go through the process of calculating bond energies. First, write the balanced equation. Then identify all the bonds that are broken in the reactants and all the bonds that are formed in the products. Use a bond energy table to find the energy required to break each bond and the energy released when each bond forms. Add up the totals, energy absorbed to break bonds, and energy released when bonds form. Finally, subtract the energy released from the energy absorbed to get the overall energy change. A positive result means endothermic, negative means exothermic. Let's work through a typical exam question. For the reaction H2 plus Cl2 giving 2 HCl, we break one HH bond and one Cl-Cl bond, absorbing 436 plus 243 equals 679 kilojoules. We form two HCl bonds, releasing 2 times 431 equals 862 kilojoules. The overall energy change is energy absorbed minus energy released, 679 minus 862 equals minus 183 kilojoules. The negative sign indicates an exothermic reaction. Always show your working and include units. Watch out for common pitfalls. Many students mix up exothermic and endothermic. Remember, exothermic releases energy so surroundings get hotter. When calculating bond energies, always multiply the bond energy by the number of bonds in the balanced equation. On reaction profiles, activation energy is the height of the peak from reactants, not the difference between reactants and products. And always include the sign of the energy change, negative for exothermic, positive for endothermic. To wrap up, remember that exothermic reactions release energy and increase temperature, while endothermic reactions absorb energy and decrease temperature. Reaction profiles graphically show the activation energy and overall energy change. Bond breaking requires energy, bond making releases energy. The overall energy change is calculated by subtracting the total energy released from the total energy absorbed. A negative result means exothermic, positive means endothermic. Master these concepts and calculations to secure top marks in your exam.